Evaluating expressions with zero and or negative exponents. This is Mr. Tretna. These will be our notes for Math 1 from Clovis High School. So, did you hear about the man who stole a calendar? He got 12 months. Smash the like button as we go through these notes. Okay, so in today's notes, we are going to be looking at how to evaluate certain expressions. So the first thing is, before we actually look at, and we're going to look at 3 different examples, we need to make sure that we understand what the word evaluate in regards to math class means. So the word evaluate, whenever you're asked to evaluate something in a math class, what they're really asking you to do is they're asking you to find the exact numerical answer. Okay, so that means almost all of the time, when you're done evaluating a problem, your answer will be a numerical, a number value. It usually will not involve x's or y's or z's or variables or anything like that. So in today's lesson, we're just going to go over how to evaluate each expression, and we're going to do 3 different expressions when x is equal to 2, y is equal to 3, and z is equal to -2. So what that means is that for each one of the 3 examples that we are going to look at, and each one of the 3 examples that we are going to evaluate, every time we see an x, we're going to substitute the value of 2. Every time we see a y, we're going to substitute the value of 3. And every time we see a z, we're going to substitute the value of -2 into whatever expression I'm giving you. And then we're going to work it out by following the math operations to get an exact numerical answer. So the first example will be an example that involves a coefficient, and in this example we'll look at it just involving an x value with an exponent of 3, and then a z value with an exponent of 2. So in this problem, this expression, all the exponents are going to be positive. Okay, so in order to evaluate this, the first thing that we have to do is we're going to have to substitute a positive 2 in the place of x. So the 3 we're just going to leave alone. The positive 2 we're going to substitute in the place of x, and then we're going to substitute a -2 in the place of the variable z. Okay, and notice whenever I substitute, and you'll see me stick with this throughout this these notes, this lecture, is that whenever you substitute a numerical value in the place of a variable, always put that numerical value in parentheses. Okay, so now, whoops, this is supposed to be an exponent of 3. Thank you for catching that, Ryan. I appreciate that. Okay, so that's a 3 right there. All right, so now we're just going to evaluate it. So I'm going to follow the order of operations. So the order of operations say I need to work out the exponents first. Okay, so this 3 does not have an exponent, so I'm going to just leave it alone. And then I'm going to work out 2 to the 3rd power. So 2 to the 3rd power means 2 times 2 times 2, and that's going to be 8. So now my expression is going to become 3 times 8, and then -2 to the 2 power means -2 times -2, which is positive 4. And then to evaluate it, I'm going to multiply these 3 values together. 3 times 8 is 24. 24 times 4 is 96. So therefore, in example number 1, the expression evaluates into 96. Okay? In example number 2, we're going to give you an expression, and in this expression I'm only going to involve one of the variables, and we'll just involve y, but then I'm going to involve a negative exponent, like let's say -3. Okay, so now when you're evaluating an expression that has a negative exponent, the first thing that you need to do is you always need to rewrite the problem so that we have positive exponents, okay? So in other words, we need to simplify this problem first, all right? You don't want to evaluate until you have nothing but positive exponents. So y to the negative third power would simplify into 1 over y to the positive 3 power. At this point, I'm going to substitute the 3 in the place of the variable y. So now my expression turns into 1 over 3 to the third power. Now once again, notice when I substituted the numerical value 3 in the place of y, I always use parentheses. And now I just work this out to get my final exact numerical answer. So 3 to the third power, that means 3 times 3 times 3. That's 3 times 3 is 9, 9 times 3 is 27, so this problem would evaluate to 1/27th. Okay, now you can get a fraction, and that's okay. If you do get a fraction and the fraction can be reduced, go ahead and reduce it. Obviously, 1/27ths cannot be reduced. Okay, now the last example, example 3, we're going to go ahead and we're going to look at a problem that involves a negative value and a negative coefficient like -4. We'll go ahead and have an x with a -2 exponent, and then we'll have a y with a 0 exponent. Okay, so in this problem we have a negative coefficient, we have a negative exponent, and we actually have an exponent of 0. So once again, if you're evaluating, if you're ever evaluating a problem that involves a negative exponent, the first thing you want to do is you want to simplify the problem before you start evaluating. Okay, well, the -2 is, to simplify this, the -2 is the only, it's only associated with the x, so when I simplify this, the -4 does not get moved, so it's going to stay on the numerator. The x to the -2 has to get moved to the denominator, but the -2 becomes a +2. And now to simplify y to the 0 power, remember that portion right there, this entire portion right here, 0 power makes that part 1. So really, this y to the 0 power, I don't have to move it, but it becomes 1. Well, if I put a 1 right here, that would just be -4 times 1, so my numerator is just -4. Now I'm going to evaluate. So in order to evaluate, I'm now going to substitute. In the place of x, I'm going to substitute 2. Okay, so I'm going to get -4, and then x gets substituted as 2, because we know that x is equal to 2. I substituted in parentheses, and now I evaluate to work out this problem to get an exact numerical answer. Have to do the exponents first. 2 to the second power is 4. So my expression turns into -4 over 4, and that is a fraction. And once again, as I said up here, if you end up with a fraction as an answer, that's okay. It's just that you can simplify this. So -4 divided by 4 simplifies into -1.